and hand things over to Brad. So let me make Brad the presenter. He's going to be an old hand at this because he has presented for our group a number of times this year. There we go. All right, Brad, it is there for you now.
Okay, can you see?
Yep, I can see your screen. Looks great.
Perfect. So, good afternoon, everyone, or good morning, depending on what part of the world you're in. Like you said, my name is Brad Llewellyn, and I've been here a couple times, and many thanks to people who are repeatedly showing up for the different topics. But today we're going to talk about what is a data scientist and how do I become one. So one of the main reasons I give this talk is because people always ask me, you know, how did I become a data scientist, and what can they do to move down that track? And my answer has always been to those people for most of my career, I don't really know. I've just kind of stumbled, and recently I've really started looking into and reaching out to other experts in the industry and kind of coming up with a list of what everybody seems to agree with. These are the things that we can really do to land those great jobs, and I'm really glad that you guys came here to help me share it with you. So before we get started with that, a little bit about me. We've seen my name, and I work for an organization called Centelli Solutions. So if you are interested in becoming a data scientist and you need a job, especially in the Charlotte area, reach out to me. We might be able to do something. But one of the things I like to point out on this page is whenever a lot of people pitch themselves for jobs, they start by talking about how long they've done something. And if you'll notice, that's not the top of my screen here, because what I found in my research and talking to managers and hirers around is that's not really that important. One of my previous bosses had an interesting saying. He liked to say there are two types of employees. There's the employee that works the same job for 10 years, and the employee that works the same job for 1 year 10 times. Meaning that not everybody really grows throughout their career. So for hiring managers, the number of years worked at a particular job isn't always a great indicator of the capabilities of an employee. So that leads us to the question of how do we get our name to the top of that stack? How do we show that we are the capable ones? We are the ones that can really handle those responsibilities. And one thing we'll touch on a lot here is certifications are a great way to do that. And I'll mention them 5 or 6 more times throughout this talk. So as someone who practices what I preach, I have an entire list of certifications, Microsoft related, and we'll talk about what each one of those does throughout this presentation. If you like what you're here today and you want to learn more about my journey as a data scientist, you can check out my blog at breakingbi.blogspot.com, or you can find me on LinkedIn or Twitter, or you can email me directly if you would like to chat. Another thing that we'll talk about a little bit is community involvement is another great way to accelerate your career. And two of the ways I do that is, one, I organize the Charlotte BI group right here in Charlotte. So if you're in town, please come check us out. We're the first Tuesday of every month. And I'm also a frequent member and speaker at past webinars and summits and SQL Saturdays and whatnot. But we'll get to the specifics of those as we go through. I also want to take this opportunity to once again thank the Cloud Virtual Chapter and Jason in particular for allowing me to present, and of course thank all of you for coming here and listening to me talk for an hour. Like I said, one of the easiest ways to really accelerate your career is by not just attending sessions like this. Attending sessions like this is a great way to learn, but also presenting and volunteering. I know for a fact that almost every virtual chapter I've ever interacted with is looking for more presenters and looking for people to volunteer to help. And I also know the same is true for the local chapters here in Charlotte. So whatever your focus is, whatever your passion is, there are people out there that want to learn it and would love to hear you talk about it. So please get involved in the community. It's one of the best things you'll ever do for your career. Now, before we go on a long talk about what is a data scientist, it's probably a better question to ask, what is data science? It's quite a buzzword right now, which, while having the benefits, it also means that not everybody means the same thing when they say it. So I like to level set at the start of this talk so we all know the direction we're going. This chart you see here is called the Gartner and Business Analytics Data Lifecycle or something like that. I always forget the name, it's long. But what it does is it shows us the steps that most organizations take on their data journey, and it really helps us define what data science is. So most organizations start down in the descriptive area. So just tell me what happened last week. Tell me who I sold to. Tell me what I sold. Those basic questions. Then they move into the diagnostic area of why did this happen? Why were sales 10% down last week? Why didn't we make this sale to this customer? Why did we make this sale to this customer? Those types of questions. And as they get a better handle on those, they can start asking even harder questions. Like, what's going to happen next week? Who am I going to sell to? Is this customer going to buy my product if I reach out to them? Those are questions that are a little bit harder, but have more value, honestly, to an organization. And finally, the top of the life cycle is the prescriptive piece, the what can we do to make it happen? So give me a list of all the customers I should reach out to that will buy my product. Those are really valuable questions. So on this, I like to say that the top 60 or so % is data science. Anything in the predictive or prescriptive space is definitely data science. However, there's also a lot of work that can be done in the diagnostic area of helping people understand why things are happening. And in order to avoid the buzzword throughout this presentation, I'm going to try to use the word advanced analytics instead, because that seems to be a bit better representation of what we're talking about, and you'll understand why as we go through the talk. So what are we actually going to talk about here? We'll spend a few minutes going through some basic job search, interview, and career advice. These are mistakes that I have definitely made throughout my career. Everything in here is a mistake I've personally made and has cost me an opportunity. And I compiled these together to hopefully prevent you from having the same struggles that I had early in my career. Also, we'll talk about the 3 different types of data scientists I see most often in the industry. These aren't the only ones, but they certainly make up a large chunk of it. And when we talk about this, it's important to kind of open up our mind as to what a data scientist is. And the argument I generally give is anybody who's directly involved in delivering a data science product to a customer is a data scientist. And anybody who's involved in delivering an advanced analytics product to a customer is a data scientist. So as we think about that, the 3 different types we have here are first the statistician or the advanced data analyst, the advanced business intelligence architect, which is what I am, and the advanced big data architect, which is what I'm currently working to become. So we'll talk about each of these in depth as we go along. But let's start with the generic career advice. One of the things I always like to say to people when I give this talk is when we talk about bettering ourselves, and this is all about us, this is going to be the most self-centered talk you've ever heard, because there is only one person in this entire world that we can control, that we can do anything about, and that's us, and individually. So if we want an organization to invest in us by hiring us and paying us money, the easiest way to do that is by investing in ourselves. And one of the best ways to invest in ourselves is by self-paced learning. To in our free time, learn things that we need to know for our jobs, not expecting employers to teach us. One of the easiest ways that I promised I would mention is certifications. And we'll talk about specifically what certifications you can get, and I'll even provide links to them along the way that you can use to land these different types of roles you're looking for. And don't worry too much about taking notes of all the different links. There's going to be a lot of them. I will send these slides out to Jason after the talk, and he can forward them out to the group. Another way that we can invest in ourselves is more than just book learning, more than just reading. We can also build with our hands. We'll talk throughout this presentation about how we can build real skills by actually building things, and that has some additional advantages that we'll talk about too. Another major advantage of building your own project is that it's completely free in most cases. So it doesn't have any capital investment from that perspective. Also, the final thing I'd like to talk about here is attending webinars and online courses is another great way to get some free learning in. And I'm obviously preaching to the choir here because you're all on a webinar right now. But it's definitely something to keep in mind as we grow. I've watched hundreds of webinars throughout my career, and I can say that they have definitely contributed to where I am today. Next, let's talk a little bit about creating a resume. I'm not a resume expert by any means, but I have learned a few tips that people have given me throughout my career. So the first thing is we're going to talk through this entire presentation of the things we can personally do to make ourselves more desirable candidates, to make ourselves better data scientists, to really land that job. And we need to make sure that when we write our resume, we emphasize all those things we're doing. While putting in the effort is awesome, if we're not telling people about the effort, then it doesn't get us as far as it could. Also, as we're learning these different tools, whether we're learning SQL or R or Python or whatever, depending on the area we want to go, we need to make sure that's prevalent in our resume as well. So people can see that, one, we're putting forth all of this extra effort to learn, but two, that we're learning in the tools they need us to know to get started. And finally, this one's a bit of a pet peeve of mine, is professional contact information. And I always like to give a story of, I read on an article a few months ago that said there was a woman who was looking for a job, and she was just having absolutely no luck getting a job. She would send hundreds of emails to recruiters and hiring managers, and nobody was responding to her. And after about a month or so of looking, she got an email back from one hiring manager who told her, oh, by the way, I just wanted to let you know the name that displays under your email address is, this. And it was something that was completely inappropriate, something that she probably made in high school and was not funny or professional. And it was actually costing her every job opportunity she was encountering was being thrown out purely because of the name that showed up on her email address. So using professional contact information can and will change the way people perceive you. So that's it's something I like to call out to people who might not think about it. Next, let's talk about networking. Networking is the easiest and the hardest thing you'll ever do for getting a job, but it's arguably the most important. I will say that earlier in my career, I submitted my resume to probably hundreds of jobs online through application systems and job sites and whatnot, and I never once ever heard back from anybody in my entire career, ever once. Every job I've ever gotten is through networking. So how do we do that? How can we effectively network? What lessons did I learn on how to network effectively? The first one of those is LinkedIn. Everybody on this call, if you don't have LinkedIn, make an account. It's free and you absolutely should. It allows you to connect with industry professionals across the world and right in your backyard. But more importantly, we can leverage that to get our name out right now with very little effort. When I was looking for jobs a few years ago, back before I had the network built up I have now, I was new to the Charlotte area. So what I did was I asked around and found a lot of companies near me that hired for the type of job I was looking for. And I would look up those organizations on LinkedIn. I would find anybody there with the title of manager or talent acquisition specialist or recruiter, and I would send them a LinkedIn message. Hi, my name's Brad. I write a blog at breakingbi.blogspot.com. I saw that you have an opening for this type of job. I'm really interested to learn more. Would you be willing to chat with me? And every single manager, every single recruiter, every single talent acquisition specialist got back to me and said, yes, I would love to chat with you. So that was definitely the most effective way I ever found to do cold openings for jobs. Another way we can network is by going to user groups and meetups. The past virtual chapters are great for allowing us to get together and talk about things like this. They do lack in the networking aspect because we don't really get to see each other. We don't get to chat about things. People just kind of show up and drop out. So one of the things I really emphasize is find a local user group near you. For those of you that don't know what Meetup is, meetup.com is a free website that has people can host what are called meetups, and they'll talk about just about anything. There are probably a dozen meetups here in Charlotte that are directly related to the kind of work I do, and I go to a few of them depending on the topics. It's a great way to meet new people, and you can talk to those people about what they do, as well as if they know of any job openings, because they might know people who are looking for talent just like yours. So it's a great way to get your foot in the door at a place. And finally, interacting with recruiters and thought leaders. I mean, coming to a presentation like this is a great start, and you can certainly reach out to me if you're looking for help. I'm in a position to influence hiring decisions like that. But it's much better to go to these local user groups and meetups. And the individual who runs the meetup or runs the user group is likely in a position like that as well, who can talk to you about jobs in your area and companies that are hiring. They might even be able to hire you themselves. Also, the presenters at those user groups are often people in similar positions. You can talk to them as well. And depending on the user group, a lot of user groups and meetups have professional recruiters that attend them, and those professional recruiters will have an entire list of jobs for skill sets like yours. So those are all really good ways to get to know people and really find out what jobs are there and get your name on the list for them. Next, let's talk about a few interview tips. I've had the pleasure and sometimes not so much pleasure interviewing people and being on the other side of the table as well, doing the interviewing. And one of the mistakes I used to make a lot in my early career was, I kid you not, I once walked into an interview not even knowing the name of the company I was interviewing at or what they did. Needless to say, I didn't get that job. And I've had people when I'm doing the interviewing come into the interview and not know what we did as an organization, not even know the basics. And it makes it really difficult to hire someone who can't even do 30 seconds of research before an interview. So one of the most important things you can do is definitely prepare, at least know what the company does. And if you can find out the name of the person you're interviewing with, hit them up on LinkedIn and check out their profile, find out what their interests are and what their skills are. And that can give you some insight as well. Also, we'll talk repeatedly about those build your own projects we mentioned. And if you're interviewing for an R developer position and you've built an R project on your own, bring it to the interview. If I'm interviewing an R developer, I'd much rather see their work than talk about their work. So it's one of the easiest ways that we can really show people that we are competent and we are a good fit for the job. And finally, staying positive. I know that everybody, especially if you're looking for that dream job and you're not landing it, it's easy to get down on yourself. So I like to tell the story of I once interviewed a guy who was a world famous at what he did. He was just an amazing statistician. And I actually ended up turning him down, not because of anything he said, anything he did. He just wasn't a good fit for the type of role we were looking for. So we turned him down, and that doesn't say anything about his skills. He's an amazing statistician. He just wasn't the right fit for us. So it's important to keep in mind that interviews are rarely about personal things. They're often about whether or not you're a fit for the organization. So it's important to stay positive. And finally, a basic recap of the career tips we talked about. Training and certifications are the most important thing you could ever do. And I'll say it again. If you're not willing to invest in yourself, how can you expect an organization to invest in you? Also, for those of you that are currently employed or have an advisor or an instructor or whatnot that knows you reasonably well, ask them for guidance. Ask them, hey, can we sit down on Friday for 30 minutes and talk about my career? I'd love to know ways in which I can improve. Most managers will agree to that. Sure, I would love to sit down with you. And they'll give you all sorts of advice about here's areas you're strong and here's areas you're not super strong. And then that can give you real good tactical ways to improve. And I can tell you that my career has absolutely changed since I started having one-on-ones with my managers, because it really shows me precise ways in which I can improve. And finally, stay positive. I've had managers in my career tell me things that hurt my feelings, honestly, things that, hey, you're really not very good at this. You really need to improve in this area and it's causing you problems. And it's important to stay positive there and realize that you asked for guidance and maybe the guidance isn't what you want to hear, but it's guidance nonetheless. So definitely stay positive and remember that you're improving yourself and that's all that's important. So let's get down to the real topic here. Let's talk about the three different types of data scientists. First, we're going to talk about the statistician or the advanced data analyst. This is what most people would call, a traditional data scientist. So what do they do? The picture we see on the right here is a program called SAS. We'll talk about it briefly, but not in too much depth. Basically, you can use SAS to build predictive models for all sorts of things. But this type of individual, they often focus on the individual analyses. For instance, sales were down last week, and boss comes in and tells you, hey, John or Jane, I need to know why sales were down for last week. And all right, I'm off. And your job is to bring the data together and find out why sales were down last week. And that may involve building some sort of model. It may not. And it all depends on the organization you work for. But the key there is the focus here is often on individual things. It's on a very dynamic day-to-day. So what exactly does this person do as far as their work? They do a lot of cleaning data. For those of you on this call that are data professionals, you'll understand what clean data means. But if you don't, basically data has all sorts of ways in which it isn't quite ready for analysis. There might be values that are missing. There might be records that you don't really want to include in your analysis for whatever reason. And cleaning up that data, that's called cleaning. So once you've cleaned up all the data, then you have to build and evaluate your different types of models. And then once you've developed the model that really gives you the answer you're looking for, what am I expecting to sell next month? What should our budget be? Why were sales down last month? Whatever you predicted, you have to compile that and present it to leadership. So that's effectively what that job does. If that's the type of job you're looking for, here are the type of titles that you can find. If you see something called data scientist, that is probably this job. I put an asterisk by it because it isn't always, hence the topic of this entire presentation. So read the job description just to be sure. And we'll talk in a minute about the different tools and whatnot you can look for in that regard. Also, data analyst sometimes falls in this category. It also has an asterisk because data analyst can mean anywhere from a hardcore Excel jockey to a senior data scientist, and it really depends on the job description. So definitely read the job description there. And also, if you find anything called statistical analyst or statistical modeler, it's very likely to be this type of job. With that in mind, what are the job requirements for this job? This is the one job that has the highest barrier to entry here. In order to get a job as a statistician or an advanced data analyst, you really need some sort of math or stat background. I'm not one of the ones who thinks you need a PhD or even a master's to do it, but you'll have a very hard time even getting an entry-level position if you don't have a good understanding of the differences between linear and logistic regression and decision trees and things like that. If you do have that type of background, or you want to train to get that type of background, remember, training is always an option, and I'll give you some links for that here in a minute. But if that's the type of job you want to get, then the two most common languages used are R and Python. R is a very old language. It's been around for, I don't know, probably 30 years or so at least. Python's a bit newer in its current state, but it's gaining a lot of traction around data science, and it's becoming the industry standard for data science development. There's also a for-profit tool called SAS that has pretty good market penetration in very large companies. So if you're working for banks or insurance companies or things like that, you'll often find SAS there. The downside with SAS is that it's very expensive. So it's really only affordable to the largest of organizations. So if this is the job you want, where can you get that first step? Where can you get that free online training? If you want to learn more about R, there's a website called R Studio that has a set of webinars that'll walk you all the way from creating your first bit of R code and how does R work, all the way up to how do you build these advanced data science algorithms using R. So just about anything you want to learn you can find there. Python's a bit harder because I wasn't able to find a good single site, but I've found plenty of information on Google and YouTube about it. The one caveat I have there is be sure you're specific about Python for data science, because Python's also a general purpose programming language that's really common in web development. and you don't want to, while there's nothing wrong with a web development career, it's not the purpose of this talk. So also, if you want to learn more about SAS, SAS has their own webinars on their website that you can find at that link right there. So we've watched a few webinars. We've said, yeah, this is really the route I want to go down. What's my next step? My next step is to build something with my hands so I can get real hands-on experience with the tools. In order to do that, there's a website called Kaggle. It's a really common website. They host basically advanced analytics competitions. For instance, if you ever heard the old competition of Netflix released a challenge saying that anybody who can make a better recommendation algorithm than Netflix, they'd pay $1 million. And they hosted that through Kaggle, actually. So you'll find a ton of different data sets up there. And more importantly, you'll be able to go to each of the different pages, and you can see what other people have done. So you can see people who are just getting started, just like you, what they've done, as well as you can see some of the what are called grandmasters, the best in the world. You can see what they've done, and everywhere in between. So it gives you a really good opportunity to, no matter where you are in your journey, learn from someone who's just slightly better than you. As far as the tools you would use for that, R and Python are free. You can Google them and download them right now. SAS has a 14-day trial that you can use if that's what you're looking for. And none of them are really better than others. We talked about the different use cases. If you're looking to go into tool agnostic consulting or work for most organizations, R and Python are really good bets. Like I said, Python being the king as of now, and SAS is good if you want to go into financial or insurance or things like that. So now that we have watched a few webinars, we've built our own project. We got real good hands-on experience. How do we prove to everyone else that we are experts in this field? Certifications are the answer. So where can you find good certifications? Well, for R, there is a course on Coursera called the Johns Hopkins University course in data science. It walks you all the way through how to get started in R for data science, how to do all the different things, all the way up to building your own machine learning algorithms and all that sort of stuff. That is $49 a month if you want to pay for that. As far as Python, there is a course, I found a good course on Edureka called Python for Data Science, and it's $389 per course. And SAS offers their own list of certifications for $180 per. Depending on the crowd, I sometimes get cringes when you look at these numbers. I mean, you got to pay hundreds of dollars to get certifications. And the best thing I can tell you is the certifications I've gotten, the amount that anybody has spent on certifications, I actually haven't paid for my own because I've had employers that will. And for those of you that are in that situation, definitely take advantage of it. If your employer is willing to pay for your certification, take them up on it. But even if you had to pay for them yourselves, I've spent maybe $1,500 in my entire career on certifications. Granted, my employer spent $1,500, and I've gotten way more return than that in salary. So these are great ways for you to invest in yourself, even though it does require a little bit of upfront capital if you have to spend it. So with that in mind, we'll take a breath, and then we'll move over to the Advanced Business Intelligence Architect. What does this person do? Like I said before, this is what I am, and I'm really passionate about this one. This is actually part of the impetus for this talk. So what exactly does a Business Intelligence Architect do? So business intelligence is all about building what are called relational structures. And we can see on the right side, we see a snippet of SQL Server Management Studio, which I'd imagine most of you on the call have seen before. Basically, relational structures are sets of tables. So it can easily be thought of as just an Excel file that has a bunch of different tables, but those tables have relationships to each other so that you can connect them and create whole new data sets by combining them. And that's effectively what a relational structure is. And as you get more advanced in that, the structures get more and more complex. What does this person do? A lot of it is creating pipelines. So a large chunk of business intelligence budgets go to moving data from point A to point B and reshaping it in some way. Those are often called pipelines. And when that data lands in its eventual destination, we have to put it somewhere, and that's called a database. So creating those pipelines and databases is a lot of what this role entails. Also, once that data lands where it needs to go, we build a lot of reports on that because leadership often doesn't care whether the data lives in database A or database B. What they care about is the insights they can gain out of it. So building those reports is really the whole goal of the endeavor. To relate this back to the data analyst role, this role has a lot more long-term view of things. It's often not a very dynamic day-to-day. You'll do similar tasks, but I personally get a lot more pleasure from the construction aspect of it because you feel like you're building something. Because over time it grows and grows and grows until you've built something massive. So it distinguishes itself in that regard. If this is what you're looking for, what type of titles can you search for? Anything called report developer or database developer is often a good bet. A newer term popping up for this type of role, business intelligence, seems to be on its way out a little bit, and the new term taking its place is data engineering. I would be a little careful with that though, because data engineering could also be big data engineering, which is not the same, and we'll talk about that here in a few minutes. So definitely read your job descriptions. And data modeler is also one that sometimes pops up. Again, read the job descriptions because data modeler could also mean predictive modeler, which would be the previous role we talked about, not this one. So with this in mind, what are the job requirements? The job requirements for this type of data scientist are substantially less than what they were before. In fact, I would say your degree or your previous experience is largely irrelevant in getting started in business intelligence. As long as you're the slightest bit technical, you can pick up some of these tools. And which tools would you use in that case? Everything I have mentioned here is Microsoft, and that's not just because I'm presenting to a Microsoft group. It's because I've been watching Microsoft for the past 5 years or so, and they really did go from a company that honestly wasn't the best back in SQL Server 2008 R2. Honestly, wasn't a better tool than Oracle. It really wasn't. But now Microsoft has made such great investments. Their new leadership has really made great investments to the point where just about any aspect of the data analytics world, Microsoft is a key player, if not the best. So I have no qualms with people being Microsoft centric at this point. It's a very good decision. And with that, if you want to go in the database development route, SQL Server's very often a tool used to do that. Another tool that we'll talk about at length here in a minute is Power BI. It's a great way to get started. And something called Microsoft Azure, which is Microsoft's cloud service. And if you're looking to get into data analytics, especially advanced analytics, you really need to get involved in the cloud because that's the future of analytics. So if this is what you're interested in, where can you find that free online training? All of this being under the Microsoft umbrella has its advantage, and that advantage is that Microsoft has honestly the world's best online training. Their online training is tremendous. You can go to mba.microsoft.com, that's the Microsoft Virtual Academy, and you can search for just about any subject area you want to search for. You want to learn Power BI, there's 100 webinars on Power BI up there. You want to learn SQL Server, there's 100 webinars on SQL Server. Also, since Microsoft is the one who sells the exams as well, you can search for an exam. Let's say you want to take, I'm making up an exam number because I don't remember them, 770. You want to take exam 770. You can search Microsoft Virtual Academy for exam 770, and you can watch a video specifically created to help you pass that exam. It really has that benefit. Also, there is a consultancy out of Jacksonville, Florida called Pragmatic Works that I'm a really big fan of. They offer free webinars. I think it's every Tuesday. And you can actually look on their website and look through their entire history of free webinars. They have over 100 webinars on pretty much everything Microsoft data. So if you're looking to learn more about Microsoft data, You can learn just about anything you need to from those two websites there. So you've watched a few webinars and now you want to build your own project. How do you do that? This is where I can't emphasize Power BI enough. Power BI is, over the past couple of years, has skyrocketed its way to the top of Gartner's list of BI tools, and for good reason. Basically, Power BI can help you learn anything you need to learn in the BI space. It can help you learn how to query data. It can help you learn how to model data. It can help you learn how to report on data. And on top of that, it is completely free. So there's no reason, if this is the type of role you're looking for, that you shouldn't be getting familiar with that. In fact, I heavily push here at Centelli that everybody here should understand Power BI because it gives us such a good avenue for presenting to stakeholders and customers. Also, as you see, Power BI has some sample data there on their website you can use. They even have some reports already built so that instead of starting from scratch, you can see what somebody has already built, and it'll give you a good starting point. If you want to go more of a development route, you don't have to go with Power BI. SQL Server 2017 Developer Edition is completely free. You can find it at that link right there. So if you want to get started building databases and tables and whatnot, we have great access there. Also, Azure offers a free trial. You can sign up at just Google Azure, and you can sign up for a free Azure trial. And you can actually, with the click of a button, install an Azure SQL database that comes pre-populated with data. So it gives you something to work with right away. It also gives you good exposure to Azure in general. Now that we have done our pre-online training, we built a couple things and gotten our hands dirty, where can we find good certifications? So all of these are $165 per, and they come from Microsoft. The SQL Server and the Azure links here reference something called an MCSE, if you see that term there, and you might have also seen those on my list of certifications. From a data analytics perspective, there are two top-level certifications you can get from Microsoft. They're called MCSEs, and they're Microsoft Certified Solutions Expert, and they are Data Management Analytics and Cloud Platform Infrastructure are the two that are related to analytics. Basically, Data Management Analytics covers a lot of the analytics side of things, so anything from core SQL Server functionality out to Power BI. In the Power BI exam you see here, 778 falls under that in MCSE, as well as Azure SQL databases out there, reporting services is out there, analysis services is out there. Most of the things that fall under the traditional analytics stack would be there. Cloud Platform and Infrastructure, on the other hand, covers how to build things in Azure a lot. It is kind of development focused, and it's if you want to be a traditional business intelligence architect, you probably don't need it. But if you're looking to maybe branch into big data eventually or something like that, it can come in really handy. One of the paths I really like to give people here is, if this is what you're looking to do, these MCSEs take 4 or 5 exams total in order to get the certification, meaning you're going to fork out $600, maybe even $1,000 in exam costs just to get the certification. So one of the paths I like to give people to do that is, instead of going straight for the MCSE, you can start with the Power BI exam, just take 778, pay for that out of your pocket, and walk into a Power BI report developer position. And from there, let your employer pay for the rest of the exams to finish up the MCSE for you. And that's a really good path that can get you into most organizations. So with that, we will move on to the Advanced Big Data Architect. And fear not, we will review these at the end to give a little bit of a lasting thought around them. But for now, we'll move to the last one, the Big Data Architect. So this is an awful lot like the Business Intelligence Architect, except there's a word distributed there. Instead of building relational structures, they build distributed structures. So relational is a very strong concept, and we won't get into what it means here, but basically it has constraints. And its constraints are, your data can only be up to a certain size. You know, if you're Amazon and you have, I don't even know, 100 trillion orders on your books, relational is not the place for something like that. If you're Facebook and you have 1 million messages a day that go through your system, maybe relational databases aren't the route for that. Or if you are some other type of company who deals with unusual data types like pictures or videos, Those don't fit well into a relational structure either. So that's where distributed structures come in. And if you notice the architecture here on the right side, it looks very rudimentary compared to what we saw for the relational, and that's because big data is not nearly as mature a field as BI. BI has been around for 20 or so years. Big data has been in its current state for maybe 2, and honestly, it's still massively maturing. So when you're dealing with BI, you get easy tools like Power BI you can use, and SQL's an easy language to learn. When you're dealing with big data, you've got to learn languages like Java and Scala and Python, and those aren't nearly as easy to learn. Also, maintaining these what are called HDFS infrastructures are gnarly in and of themselves. So it's certainly not as mature a field, and it's a bit more difficult to get into. But what does this person do? They still create pipelines, but like we said, those pipelines are a lot more complicated because physics gets in the way, honestly. When data gets up to a certain size or speed, then physics becomes a problem. Also, they create quote-unquote databases. Those databases don't often resemble what you'd see in SQL, but they are still databases nonetheless. They're repositories for data. And they perform analyses of that data, which, as we said before, can be difficult in its own right. If this is what you're looking for, what type of titles should you find? Anything that says big data engineer or Hadoop developer are definitely going to be this type of role. Also, you might find this under data engineer as well. But like we said, check the job description there because that could also mean a SQL data engineer. What are the job requirements here? They are definitely some tighter job requirements than you had for the BI space. You're pretty limited to, you need a strong background in mathematics, stats, or computer science will also do as well. Which the tools that are most often used is a tool called Hadoop, and Hadoop is like the king of big data right now. And we won't get into what it is, but basically it's the industry standard for all things big data right now. One of the common languages used to deal with big data structures is Python. You also have languages we talked about earlier like Java and Scala are also used there, but those are hardcore programming languages, and they're not quite as easy to grasp if you don't have a computer science background. Also, we specifically mention Azure here because I have met very few organizations that are spinning up new Hadoop infrastructures on premises. Basically, on-premises big data infrastructures are extremely difficult to maintain, and they require a lot of very expensive skill sets to do so. And a lot of the public clouds are making that a lot easier by offering to do all that hard work for you, and Azure is one of those. Azure has a set of resources called HD Insight that allow you to spin up big data systems with the click of a button and not having to worry about managing the whole distributed Linux backend. If this is what you're looking for, where can you find some free online training? Hadoop is owned, patented, I'm not sure what the term there is, by a company called Hortonworks, and they have their own webinars. Also, there is a section of Microsoft Virtual Academy called Data Series for Analytics, and you can search for it like that, and it has a bunch of different videos on how to use the different Hadoop configurations on Azure. The same links we saw before for Python and Azure here. And once you've watched a few of your webinars and you wanna build something on your own, Hadoop itself is open source. You can find it at that link right there. However, I would say that's not a simple task. If you don't have a computer science background, you're going to find it very difficult. In fact, it's beyond my skill set to spin those up on my physical machine. You'd have to provision multiple Linux VMs and run them simultaneously and things like that. It's a nightmare. So this is where Azure really comes into play. If you want to get your hands dirty in big data, Azure is a much easier option. Take your Azure trial and start spinning out some HD Insight clusters and playing with them there. That'll give you a really good way to get some hands-on experience without the awfulness that is on-premises Hadoop. Also, if you're interested in finding data sets for that, Kaggle also has data sets that you can spin up there as well. Once you've done all that, you need some certifications. So Hortonworks offers Hadoop certifications at $100 per. That's nice of them to be pretty much the cheapest we've seen so far. Python has that same course we've seen before. We've seen the Azure link before to the Cloud Platform and Infrastructure, MCSE. There's also an MCSA called Data Engineering with Azure that has just been released, actually. It's still in preview. And that covers things like HD Insight and Data Lake, which are Azure versions of those big data technologies. So with that, let's review what we've talked about, and then I can open it up to a few minutes of questions. So the first one we talked about was the statistician or the advanced data analyst. This person builds predictive models all day, every day. And this honestly has a high barrier to entry outside of math and stats. The demand for this type of role is currently pretty high. You can find a lot of them. In fact, my organization, Centelli, hires a lot of them. We will likely see this begin to decrease in the next 5 to 10 years or so. That's because there are a lot of organizations like H2O that are building driverless machine learning tools that do machine learning for you, cut the human out of the equation altogether and build the predictive models for you. And those are very interesting. But honestly, those are probably going to be your children's problems, not yours. The advanced business intelligence architect is the next one we talked about. They focus on building relational structures. So instead of building the predictive model itself, they build the structure around the predictive model. This has a very low barrier to entry, and it's where I would honestly recommend anybody who's looking to become a data scientist and doesn't already have a lot of industry experience. This is probably the easiest route to go. Also, demand here is really high, and it's going to remain stable for quite some time. In fact, you can look up Power BI report developer on any resume website, and you'll probably see hundreds of job postings for it. Finally, you've got the advanced big data architect, which just like the BI architect focuses on building structures, but they're the distributed version instead of the relational version. Like we said, it does have that high barrier to entry because the field's not entirely mature yet, so it's got some difficulties around that. And honestly, demand's pretty low right now. There aren't a lot of organizations hiring for Hadoop talent, just because most organizations aren't ready for that sort of infrastructure. But this is where we're going to see the jobs of the future. In 10 years, we're going to see a lot more of these types of jobs, which is why I often recommend to people that you either get started as either a advanced data analyst or an advanced BI architect, and then move into big data as the field matures. So with all that, where do you start? First, choose a role. Choose which one of these really fits you best. And there's no right or wrong answer there. Just choose the one that you like the most. And if it doesn't turn out to be the one for you, you can always switch later. Follow the provided links here to find that relevant certification that you want. And then prepare for that certification with the books and the webinars and the build your own projects that provided links to here. Finally, get certified and put that bad boy all over your resume, all over your LinkedIn, all over your About Me slides, as you can see. But the most important part here is don't do that in a vacuum. Don't just go home at night and read books and watch webinars and build on your own. Get out to your user groups. Get on LinkedIn. Attend these virtual groups. Better yet, present or volunteer for these virtual groups, as well as attend your SQL Saturdays or even help run your SQL Saturday. They always need help running those. And attend Past Summit or volunteer for Past Summit. Get out there and network as much as you can. And I promise you put this little bit of investment in yourself and you'll see massive gains come out of it. Well, with that, I definitely want to thank you for coming here to listen to this. I really hope you got a lot out of it. And there's all my contact information in case you want to reach out to me. And I'm open for questions now.
All right, thanks, Brad. We do have a couple questions here. So the first question is does linear and mixed integer programming still have a role in business intelligence? If so, why is it so seldom mentioned anymore?
To be honest with you, I've been in the BI space for years, and I've never heard either of those terms. I think I heard linear programming once, so I would have to say that if they are around, they're not common.
All right. And then what aspects of mathematics should one focus on for a data scientist job?
Oh, that's a really good question. So I would say one, predictive modeling is huge. So the basics of regression and classification and decision trees and things like that, absolutely understand those basic concepts. And you can find all sorts of like Udemy courses or Edureka courses and stuff like that. But also be tool specific, meaning instead of just learning data science in a vacuum, take that R for data science course or that Python for data science course. It'll teach you the math and the tech so that you're ready for that job.
All right. And how helpful is DBA knowledge for a data scientist job?
That really depends on the data scientist. I will say that as a BI person, I've run into a lot of issues over my career where having some DBA knowledge has helped. And if you want to go into big data, DBA knowledge becomes very, very helpful because big data has all sorts of issues with performance and whatnot. As far as being a traditional data scientist, being that data analyst, probably not much unless you can carve out that unique space of using predictive models to predict things like server downtime and server maintenance.
All right. Are Azure ML skills marketable?
Oh, you see hold on, let me move my thing. I don't know if you can see the thing, but I love Azure Machine Learning Studio. I give multiple presentations on it. Marketability is a tough one there. That's because hiring managers don't really understand it. But I would say you're going to have a hard time finding an Azure ML specific job. But if you can find a BI job and then insert your Azure ML skills, that's the path to success. In fact, that's the exact path to success I took. So Azure ML skills are not necessarily marketable, but you can definitely use them to propel yourself from traditional BI or traditional DBA into one of these other roles.
I think we have time enough for one or two more here. So let's see here. Are there hands-on labs for Power BI?
Hands-on labs. Interestingly enough, I've for those that don't know, I think this person is referring to hands-on labs from Microsoft.
Yep.
Interestingly enough, the company I used to work for, Valorum, builds the hands-on labs. That's the only reason I know about them. I've never actually been out there. But I would encourage you to check on your own because honestly, I don't know the answer to that.
All right. And that looks like those are all the questions that we have for today and the time for those today. So Brad, thanks again for presenting. And thank you everyone for coming out and attending today's session.
Thank you.
Yep. And everyone have a great day.